Okay, welcome to the set of recordings where I'm going to demonstrate some of the simple tricks in mathematics which you need when you're going to embark on a study of general relativity. So, general relativity is done by physicists, and strangely enough, physicists tend to have a different type of notation from mathematicians. And one of the things they do is they write sums with Einstein notation instead of using sum signs, those sigma things of mathematicians. So if a mathematician wrote something like this here, okay, a sum, say, on I, and then a sum on J of, I don't know, a matrix, which would be A, so you would have the generic matrix item, which is Aij, Xa, Yj. So this is a vaguely quadratic type of expression. So if a mathematician were to write this, then Einstein would have written this very simply. Aij, Xi, Yj. So what Einstein did was he got rid of the sum signs. So you can see that the sum here goes from I equals 1 to I equals 3 probably, or 4 if you prefer, okay. And j equals 1 to j equals 4. And what we've done is we've taken this part here, moved it down, and this becomes our whole expression. So the trick here is that we're summing the indexes which are repeated twice. So I is repeated here and here, j is repeated here and here. So basically what we're doing is first we're summing on the i's, then we're summing on the j's a second time, okay, which is exactly what happens here. We sum on the i's and then on the j's. We can do it the other way around, sum it first on the j's and then on the i's by the usual commutativity of addition and associativity. It's the same thing. Okay, Einstein used to call this, very cynically or sarcastically, my great discovery in mathematics. And I will show some typical patterns which occur with this Einstein notation in the next video, but in this one I'll still give one simple example, which is a standard, scalar product. So suppose you have a vector x and a vector y, okay, so you will do sigma of the x, y, yi for, say, I equals 1 to 4, okay. And how do you note this in Einstein notation? Well, you just take this part here, and this here becomes xi, yi. So we've got rid, as you can see, of a lot of that messy, strange Greek stuff on the left-hand side. It's much easier for the typesetter, and it's easier to read as well, provided you know the key trick. Every index which appears twice denotes a sum. Thank you for following, and see you hopefully in the next video for some typical usages of this.